Welcome back, ladies and gentlemen. So today we're going to be talking about solving and graphing compound inequalities. So just a quick heads up, the big difference between inequality versus equation always has an equal sign, okay? And, you know, as far as these symbols go, we're going to see different things, okay? So when you see this symbol, okay, opening to the right, this is less than, okay? So if you see something like less than, you could say like x is less than 5. Now how that looks as far as drawing it, you would use an open circle at 5 and everything to the left. Okay, there you go. Now if you have a line underneath it, it's less than or equal to. Okay, so x is less than or equal to 2. There's 2. That just means you close the circle in. Alright, so it's important to note the difference between the two. Equals, okay, obviously x equals 1. So actually what that looks like is on the number line if you ever had to graph this, which you never really do. You should just put a filled in circle at 1. Not equal to, okay, not equal to. Alright, so you could say x is not equal to -2. You have yourself a number line. There's -2. You just do an open circle. Cool. This would be greater than. So x is greater than -3. I'm just picking random numbers, by the way, so it's not like everyone's going to be this. Open circle, but greater than is above. Okay. And finally, greater than or equal to. Okay, so x is greater than or equal to, I don't know, 12. All right, so you've got 12, filled in circle, everything to the right. Pretty good. Okay. So there's two really big compound inequalities that we got to talk about. You have your and compound inequality, and you have your or compound inequality. When you have an and, it's basically when they meet in the middle, like this and this combined together. Okay. Typically, you see it written like this. -2 is less than x is less than 5. You notice that x is contained in between them. Or is when they're going in opposite direction. X is less than or equal to -1, going this way, or x is greater than or equal to 2, going that way. All right. So let's take a look at a few examples in the back. Okay. So we have an example over here. Okay. And what it says is -3 is less than or equal to -4 plus x is less than or equal to 2. So I like to call these triple inequalities, which you have like 3 different sides, your left, your middle, your right. I want to get x by itself. I add 4 to the middle, but if I add 4 to the middle, I got to add to the left and to the right. This gives me 1, that cancels out, that gives me 6. What that graph would look like, you've got your number line, you're starting at 1, closed circle, because it says less than or equal to, and it goes to 6, closed circle. And because x is in the middle, you would graph or shade in the middle. Boom, done. Okay. So a second example to work through, just so you guys can see the actual math. I will have x in the middle. I can add 3, add 3, add 3. Alright, so I would get -7 is less than or equal to x, which is less than or equal to 12. Okay. See if I can fit this in here. I apologize. -7, 12, closed circle, everything in the middle. Okay. Very good. For your or, right? What you're doing here, or rather using a subtraction. So I've got this one or that one. I like to cover them up. So 5 is less than y plus 1. Subtract 1. There you go. And then over here, you can subtract 3. Okay, you're good. So like just what you do to 1. Okay, you're good. So how that looks, y is greater than 4. So greater than 4 goes this way, but y is less than -1. So -1. Go back. All right. Over here, if I subtract 3 from both sides, -1 is less than y. Or I want to subtract 4 here. -7 is greater than y. So we're going from, oh, I'm sorry, hang on. Y is, sometimes it helps if you rewrite them. So like for this one over here, I could rewrite that as y is greater than -1. Or y is less than -7. So there's my -7. open circle to the left. Here's my -1, open circle to the right. In good shape. Okay, using division, you can divide all three sides by 5. 5 is less than x is less than 0. I like to flip this around. 0 is less than x is less than 5, because it just makes more sense, like on the number line. How that one looks, okay? Notice that this time we had less than symbols instead of the less than or equal to up there. 0 and 5, open, open, in the middle, boom, done, okay? Now, please note over here, this is very important. We divided by 5 there, no big deal. When you divide by a negative number, okay, -18 divided by -6 gives you a +3. But that inequality sign must flip when you divide by a negative. Must flip when you divide by a negative. Alright, so what that looks like is -6 is less than x is less than 3. Open, open, everything in the middle. Okay, cool. A few more here. Using multiplication, alright, same idea. You multiply by the bottom number. If you multiply by a negative, that sign's got to flip. Okay, so x is less than -8. Alright, there's -8, open circle, to the left, boom, done. Over here, I'm multiplying by a positive number here, so I am not flipping anything. So x is less than 18, open circle, to the left. Okay, again, you only flip the sign if you're multiplying or dividing by a negative. Finally, mixture of properties. Now, don't get lost here, but we're adding 2 to all three sides. 12 is less than 3x is less than 21. Dividing by 3. 4 is less than x is less than 7. Sweet. So it's the same idea as you solve an equation, but you have inequalities. Just keep the inequality sign pointing in the right direction. You're in good shape. Okay, in the middle, bam. So here, I want 2x by itself. I got to get rid of this -3. +3, +3, +3, -4. Is less than or equal to 2x, is less than or equal to 8. All right, divide by 2, divide by 2, divide by 2. -2 is less than or equal to x, is less than or equal to 4. See if I can fit this over here. I apologize again. You've got -2, you've got 4, it's in the middle, so closed, closed, boom, done. Okay, very nice. Alright, last few here then, guys. Okay, a baseball team has $1,000 spent on supplies. The team spent $185 on the new bat. New baseballs cost $4 each. Here's your inequality. $185 for the bat, $4 per baseball, and they only have $1,000. So it makes sense that are less than or equal to $1,000. It can be used to determine the number of new baseballs that can be purchased. Which statement about the number of new baseballs can be purchased is true? The team can buy 204 new baseballs. Well, if you plug 204 in for B, 185 plus 4 times 204, that gives me $1,001. So that can't happen. Cross it off. The minimum number of new baseballs that can be purchased is 185. Well, if I plug in 185, okay, 925, that works, but do I have to spend a minimum amount for 185? No, it makes no sense. The maximum is 185. Again, no, because I can buy more if I really want. The team can purchase 185 baseballs, but this number is either the max or the min. Now we're in good business. So if you see a lot of numbers there, if you see like A, B, C, D, work your way through all the answers and see which one makes the most sense. Using the information in problem 4, what's the maximum number of baseballs that can be purchased with the remaining money? Okay, so we can actually solve this. So if I do 185 plus 4b is less than or equal to 1,000, subtract 185 over, 4b is less than or equal to 815. Let me just make sure real quick because sometimes I make mistakes. Okay, good. Divide by 4. B is less than or equal to 203.75. Now, think about this. I can't buy 204 baseballs. Okay, or I can't buy 203.75 baseballs. So the maximum, what's the maximum of baseballs? Maximum is 203 baseballs. Okay, cool. So, good job, everybody. Thanks for all the hard work. If you have any questions, feel free to do so. But otherwise, keep up the good work and good luck. We're all counting on you.